Welcome back, everybody. In this video we're going to be finding area of different figures, different shapes put together. Like this first example, we want to find the area of this shaded region. What we have here is a square, and we're going to subtract out the circle. And if you know the area of a square, you take the side and you square it. And the circle is pi times radius squared. Okay, the side of the circle is 7, so we have 7 squared. We'll do 3.14 for pi. The radius is half of 7, so the distance from here to here, 3.5. Putting all this in the calculator, 7 squared minus 3.14 times 3.5 squared, we get 10.54 centimeters squared. That's the area of the shaded region here. These little areas right here just around the circle. The square subtracted from the circle. Alright, looking at this one, it says a quarter circle is attached to the side of a square as shown. What's the best approximation for the area of this figure? So on this one, we're going to add the areas. We have a square added to a fourth of a circle, also known as a quarter circle. Once again, we have side squared. We're adding 1/4 pi radius squared. The side of the square is 4, so that gives us the 4 squared. 3.14 for pi, and the radius right here, notice that's the same distance as the side of the square. Radius of the circle is 4. Putting it in the calculator, we get 28.6 square meters. Let's look at another one here. This time we have a rectangle attached to a semicircle. Best approximation for this area. Well, rectangle plus, this time, a half of a circle. Rectangle area, 6 times 2. For the length, well, here, let me get the formulas here. Length and width, then 1/2 pi radius squared. So we have 1/2 times 3.14. Now the diameter showing right here is 3, so radius would be 1.5. 1.5 squared. Putting all that in the calculator, we're going to get 15.5 square meters. Look at this one. We have another shaded area. What's the approximation for the shaded area? So we have big circle, and we just need to subtract away the small circle. Alright, so in essence, pi r squared minus pi r squared, and the radius will be different for both of them. It says the diameter of the larger circle is 12.5. So from here to here is 12.5. If we take half of that, we're going to get 6.25. So there is our radius for the big circle. Then working on the smaller circle, says the radius of the smaller one is 3.5, and that distance pretty much from here to here. If we take half of that, 3 3.5 divided by 2, 1.75. Radius of the smaller circle, 1.75. So a lot to plug in the calculator. Just go slow. Good idea to enter parentheses, keep things separate. This area of the shaded region comes out to 113.04. And we are talking in centimeters, so it is square centimeters. Last one here. Looks like we have a semicircle and quarter circle. Here's our semicircle, here's our quarter circle, and we have a rectangle. What's the area of the figure? Well, if you take half of a circle and a fourth of the circle, you get 3/4 of a circle. Add it to the rectangle. Alright, our rectangle is length times width, and our circle, of course, pi r squared. Alright, take care of the rectangle, and an easy 2 times 12. The circle, though, is 3/4, 3.14. And the radius right here, we see that to be 6 squared. Putting all this together in a calculator, we get 109 centimeters square. And that's our video of area of partial figures or composite figures. Thank you for watching.